All right, hello, seventh graders. I'm just going to do a quick summary of the real number system that we have focused on this week. And I want to bring it back to this diagram that you went over last week as well. So quick reminder that when we looked at this diagram, you hopefully discovered that if something is inside Mrs. Cleveland's math classroom, that also means it's automatically inside Liberty Middle School, automatically inside Papillion, and automatically inside Eastern Nebraska, which is then also part of the state of Nebraska. If we had, for example, Papio South is inside Papillion and Eastern Nebraska and Nebraska. It is not part of Western Nebraska, it's not part of Liberty Middle School, and it's not part of Mrs. Cleveland's math classroom. So that's just kind of, I want you to use that comparison as you study the real number system to remember that once something is inside these smaller boxes, it's going to be automatically a part of every outer box going upward. So when we look at the real number system, we have our natural numbers, and our natural numbers, these are your counting numbers beginning with 1. So think back to when you're itty bitty and you're first learning how to count 1, 2, 3, 4, 5, 6, and so on. Okay, it does not stop with 5. That's what the ... means. Then when you start with your whole numbers, all right, one thing I want to show you guys is that these numbers 1, 2, 3, 4, 5. So more specifically, these are your natural numbers. I just included them here to represent what's going to get added into the mix there. I also wanted to talk about this 40 over 4. So every time you see a fraction, every fraction is a division problem. And if you can simplify a fraction, you want to simplify it and then classify your answer after you simplify. So for example, this is 40 divided by 4. 40 divided by 4 is actually going to be equal to 10. So really this whole entire value should be written in the natural numbers, because when we simplify that, we get a counting number, okay? So the difference with our whole numbers then is our whole numbers are going to include this number of 0, okay? So whole numbers are all of our natural numbers plus that number 0, okay? Then our integers are all the whole numbers, which include the natural numbers and 0, all right? And then now we're talking about their opposites as well, okay? So for example, the opposite of positive 15 would be negative 15. The opposite of positive 49, which is a natural number, is going to be negative 49. So these are your traditional like number line numbers. Again, notice that there's a couple of fractions here, all right? We'll learn further on in this unit how these simplify to numbers that would be integers. But for right now, just know that even though they're written as fractions, they can be simplified and they become integers. And then we have our rational numbers, which are any number that can be written as a ratio or a fraction, a over b, where b does not equal 0. That's the most formal definition. We'll talk more about that in class, but for right now, know that this is going to include positive and negative fractions, positive and negative mixed numbers, because you could rewrite this as an improper fraction. And then 2 types of decimals are going to be included in this category. You have terminating decimals, which are decimals that are going to terminate or stop. And then, so 16 and 75 hundredths is one example, -2 and 4 tenths is an example. And again, that's because these can be written as fractions. So for example, 16 and 75 hundredths, I can end up writing as 16 and 3/4. And then I could even go one step further and make that into an improper fraction, I believe 67 over 4. Okay, so now I have it in the form a over b. The other type of decimal that's going to be included as rational are these repeating decimals, so where you have a specific pattern that's going to be repeating. So if you see bar notation and then there's a set number or numbers that repeat in a pattern form, those are also going to be rational numbers as well. And again, all of these are part of the real number system. We also have irrational numbers, okay? So the real number system is overall into 2 categories, rational numbers and then what we call irrational numbers. We'll talk more about irrational numbers at the end of the school year, but for right now, the best example of an irrational number would be pi, because pi is a never-ending decimal, but there's also no pattern that repeats within it, okay? So it does not terminate and it does not have a pattern that repeats, and that's going to make it irrational. So an irrational number is going to be any number that cannot be written as a ratio or a fraction. Other examples of some irrational numbers, which we'll study later on in the year, would be like the square root of 2, the square root of 7, basically non-perfect squares. So that is just a quick little summary on the real